Alright, pre-cal, I'm back with video number 5. I know, this is a lot to do. It's a lot of lesson, but that's alright. I'm going to try to give y'all as many examples as possible. Alright, number 25. Alright, it says simplify the expression and graph both expressions, meaning the original and then simplified. To verify the graphs are identical. So first of all, put your calculator in radians. You will graph these, and that's from your mode button. And you're going to do them the y equals, you just do one and then do the other and see if you end up with the same graph. It's going to be a yes or no answer once you do all this. Now I'm not graphing it because I'm going to let you guys do that part, because look, I've been on making these videos all afternoon. So I think you guys can graph it. Just make sure you put your calculator in radians and you go to your y equals y1, y2, y sub 1, y sub 2, your y list. Alright, so let me get on one of these. Hold on. So I'm continuing problem number 25. Okay, the instructions were on the other page. So, given cosine pi over 2 minus x. Okay, so we're going to simplify this down, right? And that means we're going to simplify using the formulas. But this is going to be the first one that you graph. So this would be like your y1. Okay, you can graph that one, and then we're going to graph the simplified version. Okay, so we've got cosine of alpha minus beta. So cosine of alpha minus beta, we're going to use this formula. Okay, so we're just going to plug it in. That was a weird fraction. I don't know what I did there. That's pi over 2. That's bizarre. Okay, and then times sine of x. Alright, that is bugging me. That's supposed to be pi over 2 there, y'all. Right here. Okay, now we're just going to put in the values. Okay, so we know that cosine of pi over 2 is 0. We know we're just going to write cosine x. Plus, we know that the sine of pi over 2, right, that's your y coordinate, is going to be 1 times this word, sine of x. Let me put pi over 2 up here. Okay, so now this is going to be 0, right? So you are simply left with sine of x. Alright, so what it's asking you to do is to graph this one and then graph this one, and you can do it on the same screen, and then you're going to prove whether or not these two are identical. And then on this particular one, I'm not going to be very detailed. Your calculator would be, but you're going to end up with one graph on top of the other, basically. Okay, so this one might look a little something like this, then down here, and then up here, and then down here, and then up here. Something like that. Okay, and you're going to see only one graph. So the answer here would be yes. So they're asking you to graph both the original and the simplified, and then see if you get it. So you would say, yeah, basically that verified out. Those are the same graph. All right, so you have several of those, and they're just that easy. Okay, All right, let's see what else we got for you. Okay, now towards the bottom of your down here towards the bottom, you've got some prove the identities provided. So you're going to prove the left side can be reduced to the right side. Okay, so the left side is going to be reduced to the right side. 50. I'm going to tell you, honors, there's a star by that one. That one's challenging. I want you to give it a shot though, but it's pretty challenging. I don't think it's that hard. It's just kind of lengthy. Okay, so and then prove or disprove the statements. You're basically saying, can the left side equal the right side? Okay, and some of them are kind of silly, like 52 is kind of silly. 54, not too terrible. You're going to have to think in terms of, you're going to have to look at my solutions on that one, and I'm going to give those to you now. Just, I want you to understand the conjugates that are evolve. And then this one I want you to think about. I gave you a hint in red on your actual copy, so give that one a try. But let's see which one I want to do now. I think I'm going to try, which one was it that I wanted to try? Maybe 49. I gotta find my workouts. I know, I'm burning time here. Hold on, people. I'm sorry. Get down to the end of the day, and I am not moving as fast as I thought I would be. That's 49. Okay, 49. Pretty simple. All right, so 49 on your highlighted, cosine of a plus b over cosine a times cosine b. We want to prove that that can be reduced to 1 minus tangent of a times tangent of b. All right, so we're going to start on the left side. Okay, first thing you're going to recognize is I'm using that sum formula for cosine, and that's going to leave me with cosine of a times cosine of b minus the sine of a times the sine of b. That's just this guy. Now down here, I'm just going to bring it down and say cosine of a times cosine of b. Okay, well here is a fraction that we can decompose. Okay, you can decompose it, and this is the result of having added a fraction that brought these two together, but really truly it's not that big of a deal when you just kind of separate it out. Okay, so you could say cosine of a times cosine of b over cosine of a cosine of b minus sine of a sine of b over cosine of a cosine of b. Okay, all we did is we split the fraction. Okay, we left subtraction in the middle. It's called decomposing a fraction. Well, over here you got a slam dunk. That's just going to be 1, and we're looking for that. Over here you've got another type of decomposition, except this is multiplication, because then you've got this ratio, which you can recognize is going to be the same as tangent A, and then you have this ratio, yeah, that's right, and then this one is tangent B. Okay, so we proved it. Pretty simple stuff. You just have to recognize your decomp availability. All right, hang on. Okay, honors, here's your number 50. All right, so we have cosine of x plus y times cosine of x minus y. Got to prove it equals cosine squared of x minus sine squared of y. Now this one, I'm telling you, it's an honors level problem. There's no question about it. All right, so the first thing you're going to recognize is I've got a plus b, right? Except instead of angle A and angle, and I'm not doing this whole one. I'm going to get you set up. So this one ends up being cosine of x times cosine of y minus sine of x times sine of y. That's this guy, okay? Then we have multiplied by that the next expression, and he's going to be cosine of x times cosine of y. I'm just following the cosine, the difference formula there, plus sine of x times sine of y. Okay, now I want you to look at this for a minute. I want you to zoom out for a second. Think about this as conjugates, because that's what they are. Okay, so you can look at it like, okay, a minus b times a plus b. They're conjugates, and that's always going to leave you with a squared minus b squared. Okay, I'm going to leave you with that, and then I want you to remember one thing. When you get down to this point, remember that cosine squared of y can be turned into the Pythagorean variation of 1 minus sine squared of y. It's the same as saying cosine squared theta. These are equivalent statements, so you're going to need that. Okay, I'm not going to do much else for you, but you're going to have to use the fact that this times this will be perfect difference of squares. You will have right here, because you're going to square this, you're going to have cosine squared of x. Let me just put that right here. Okay, so you're going to have, when you go to do your a squared, you're going to square this term. Cosine squared of x, cosine squared y. Then you're going to bring cosine x down here, leave him, but convert him to 1 minus sine squared y. We have to introduce that at some point, and you're going to also just remember, you're going to factor out something down here, and when you get to the end, you're going to be very proud of yourself. Okay, so don't forget also cosine squared of x plus sine squared of x equals 1. You're going to see that as well. But that's all I'm going to give you. I want you to try to do this one. All right, honors, that's definitely up your alley. All right, guys, have a good night. I'll talk to you tomorrow. Remember, team meetings in the morning. Don't be late. Bye.